It's a revenue question. Remember, revenue is equal to quantity times price. Currently, the quantity, we have 28,000 people, and the price is $15. They say for every $3 drop, from $15 to $12, that's a $3 drop, you're going to add 6,000 people. So if I put an X here, that's going to say, a $3 drop, maybe a $6 drop, $9 drop, so forth. However many drops I make, I will increase 6,000 people every time. Now, if I multiply that out, let's see here. I'll bring my 1,000 out and get 28 plus 6x and 15 minus 3x. 28 times 15. Line this through. 420. Plus then 90x. 28 times 3, 4 2 is 84, so minus 84x minus 18x squared. So I'm going to get negative 18,000 x squared plus 6,000 x plus 42 or 420,000. Now x is equal to the opposite of b over 2a. That's going to tell me my maximum. So negative 6,000 over negative 36,000. That's going to give me 1/6. So x is 1/6. Okay, so I'm going to make 1/6 of a price drop. Okay, well, 1/6 of a price drop, $3 is the price drop. 1/6 of $3 is 50 cents. Okay, so the ticket price is going to be 15 minus 3 times 1/6 is 15 minus 0.5, 14 and a half. The attendance then, okay, if I'm going to increase by decrease the price by 1/6, I'm going to increase my attendance by 1/6 of this 6,000. Okay, so I'll plug the 1/6 in here. 28,000 plus 6,000 times the 6 is 1,000. So add those together and you get 29,000. Now the maximum revenue would be 14.5 times that 29,000, which is $420,500. This question here, the way they read it here, we're going to say that 0 corresponds to 98. So this will correspond to 1, 2, 3, 4, and then the last one, let me scroll down here, is going to be 5. Okay, so 2003 will be 5. When you type this in your calculator, what you're going to be doing there we go. Stat, edit, type in 1, 2, 3, 4, 5. Then in this 2, you're going to type in these quantities. Now you're going to go to Stat, go over to Calc, go down to Quadratic Regression, which is number 5. Go all the way down to Calculate. And there's my A value, my B value, and my C value. Notice that B is negative, so you have to put a negative in here. Alright, so my quadratic function is going to be 345.14 x squared minus 1705.66 x plus 42,903.6. Okay, now it wants us to find out how many cases will be diagnosed in 2006? Well, 2006, if we look at our list over here, it would correspond to the x value of 8. So I'm going to take this quadratic equation that I just created, this f of x, and plug 8 in for x squared. And my result should be, it's around 51,000. I'll leave that up to you to go ahead and plug that in. Going to question number 3 then. Okay, this is just they're asking what's the maximum height reached by the ball. We're going to look at that quadratic there. The maximum height, remember, is the vertex, and that's found by the opposite of b over 2a. And my variable is the variable that we use in here, so it's t. So time is opposite of b over 2a. So that's not the height. That's going to be the time in which the maximum height is reached. So if I go opposite of b, be negative 96 over 2a, which is going to be negative 32. That's going to give me a time of 3 seconds. So at 3 seconds, I'm at my maximum height. So now I'll take that 3 and run it through this function, negative 16, 3 squared, plus 96 times 3, plus then 4, and that would give me my maximum height then of 148. So at 3 seconds, I'm a maximum height of 148 feet. This question, we're finding the length in regards to the width. So the length here is going to be 2.6x. They ask us which of the following are restrictions for x. Well, x has to be positive, it has to be greater than 0, but it also has to be bigger than 6, because if I'm cutting a distance of 3 and 3 away from the sides, then the starting distance of x has to be bigger than 6. So that's what we're looking for here. X is greater than 6. Now they want to know, how can I represent v, the volume of this function? Well, volume is length times width times height. Right now, if we think about this, our width in this case is going to be x minus 6. Your length is going to be 2x minus 6, and your height then is going to be 3. Okay, so that's my volume function. Go ahead then and multiply that out, and you'll get a quadratic. It says the volume of the box must be between 600 and 800 cubic inches, between which two values must x be in order to produce this range of volumes. You would basically take this and set it equal to 600 and solve for x, and then set it equal to 800 and solve for x, and that'll give you two values for x that you need. Alright, so finishing this last part of this question, I typed this function into y equals, and then the two range values that they're asking about, 600 and 800, and I changed my window. If I know I'm looking for y values between 600 and 800, I changed my y minimum to 580 and my y maximum to 820, scale of 20, and then my x minimum and my x maximum, negative 10 to 20. Now if I graph that, it should look like this. Now the 2 points that they're asking for, the two x values that are going to keep the volume between those two things, are this x value here and the x value of this intersection here. So we've got to find those. If I go to second, calc, intersect, and locate those points. You'll find that 0, and you notice it's right now it's getting 14.6, which is not the 14.4 that they want. So I'll go back and look at everybody's and make sure that there's not an error there with their rounding. Retracting on the last question, that's where my rounding was messed up, is I typed in the wrong equation. This should be a 2.6. Graphing. So there we get our 13.1. It matches up with that 13.1. And our 14.4. Just be careful when you type your equation in that you type it in correctly.